So let's look at the differences between a low pressure cell, which is going to be known as a cyclone, and a high pressure cell, which is going to be known as an anticyclone. So firstly, we will look at the air temperature and movement. So a cyclone is going to be linked to warm rising air, and obviously that's going to take place during summer. Whereas an anticyclone is going to be linked to cold subsiding air, which will occur during winter. Can you see how the two are going to be opposites of each other? So if you can remember the characteristics of, let's say, the cyclone, obviously the anticyclone is going to be the exact opposite of that. Next, we're looking at pressure. So in terms of pressure, the lowest pressure is going to be found at the center within a cyclone. So if we take a look at the diagram of the cyclone, can you see how the reading at the center is going to be 860 millibars, right? Can you see how the lowest is going to be at the center? As you move outwards, it's going to increase. But when we're looking at an anticyclone, the highest pressure is going to be found at the center. Can you see how at the center it's going to be 1000 millibars, and as you move outwards it's going to decrease. Next, we're going to look at the movement of air, right? So within a cyclone you can have convergence taking place, right? That's going to be the movement of air into a low pressure cell. Now can you see in the cyclone diagram how the red arrows are going to be moving into the cyclone? Now that's going to be known as convergence, right? But if we're looking at the anticyclone, can you see how the arrows are going to be moving outwards, right? That's going to be known as divergence. That's going to be the movement of air out of a high pressure cell. Next, we're going to look at the wind direction, and obviously we're going to look at the wind direction in the southern hemisphere because South Africa is located in the southern hemisphere. Now for a cyclone, the wind direction is going to be clockwise, right? And it's going to look like this. But with an anticyclone, the wind direction is going to be anti-clockwise. Now in terms of weather conditions, with a cyclone you can have unstable weather conditions, and that's going to include cloudy conditions, rainy conditions, stormy conditions, and all of these are going to be considered unstable weather conditions. Whereas with an anticyclone, you can have very calm, clear, dry, stable weather conditions. Now can you see how for every single characteristic and condition, it's always going to be the opposites of each other. Now in terms of formation, this is going to be a very basic process, right? So for a cyclone, you can have your rising warm air, then we're going to have condensation taking place, and obviously then we will have cloud formation. Whereas for an anticyclone, you can have sinking cold air, which is going to inhibit cloud formation. And in terms of associated systems in South Africa, with a cyclone, you're going to have your mid-latitude cyclones and you're going to have your tropical cyclones. And in terms of your anticyclone, you're going to have your South Indian high, you're going to have your Kalahari high, and you're going to have your South Atlantic high. Now, your cyclone is going to cause rain over South Africa, and that's going to occur especially in your winter rainfall areas. Whereas your anticyclone, that's going to cause dry, clear conditions, and it's going to cause drought periods. And lastly, when looking at the definition of each cell, a cyclone is going to be an area where warm air rises, creating low pressure at the surface, right? And it's going to be associated with clouds, rain, and unstable weather. Whereas with an anticyclone is an area where cold air sinks, creating high pressure at the surface, right? And that's going to be associated with clear skies, dry conditions, and stable weather. And here are some quick and easy exam tips. Feel free to pause the video and read them, or take a screenshot and read it later when you do have the time.
Did you know that there are 5 important stages in the formation of a mid-latitude cyclone? In this video, we will be going through the characteristics, the conditions necessary for formation, the stages, as well as the effects and precautionary strategies, as these 2 topics very often come out as essay questions. Now, these essay questions typically come out for about 8 marks each, and those are a lot of marks. So first we are looking at the general characteristics of mid-latitude cyclones. So mid-latitude cyclones, also known as temperate or extratropical cyclones, are large weather systems that occur between 30 degrees and 60 degrees latitude in both hemispheres. Now remember, if they do ask you a question, but instead of saying mid-latitude cyclones, they say temperate cyclones, just know that that is the exact same thing, right? Temperate cyclones is just another name for mid-latitude cyclones. Now, mid-latitude cyclones move from west to east, right? That is known as eastwards, or in an easterly direction. So if you are asked, in which direction will mid-latitude cyclones move? Then your answer should be from west to east. Now at this point we'll go through two very important pieces of information, right? They typically cover a large area, a diameter of about 1,000 kilometers, and bring varied weather conditions including cloud cover, strong winds, and precipitation. So they're talking about the diameter, which will be 1,000 kilometers, and they are talking about the weather conditions that are associated with mid-latitude cyclones. So mid-latitude cyclones affect South Africa mainly in winter, and it generally lasts between 4 to 14 days. Now let's look at the conditions necessary for formation. So our first condition would be warm subtropical air from 30 degrees north and south meets with cold polar air from 90 degrees north and south at the polar front, which is located at 60 degrees north and south. So let's look at our diagram, as that will help us to understand this point a little bit better. So warm air that is found here, 30 degrees north, will meet with cold air, right, cold polar air, which will come from your 90 degrees north, right? And the warm and cold air will meet here at the polar front, which is located at 60 degrees north. Now this will happen in both hemispheres, so this can occur here in the northern hemisphere or in the southern hemisphere. So let's look at it in the southern hemisphere, right? Warm subtropical air from 30 degrees south will meet with cold polar air from 90 degrees south, and they will both meet at 60 degrees south, which is also known as the polar front. Now both air masses move parallel to each other in opposite directions, as we can see in the diagram, right? They are moving parallel to each other and in opposite directions. So in the northern hemisphere, your cold polar air will move south and the warm subtropical air will move north. Now there is frictional drag between the air masses, and it causes them to interact with each other. Now you may be wondering, why will frictional drag occur? Right? What causes it to occur? Right? There are three reasons why it will occur. And now the first reason will be because of a difference in the speed of both air masses. Remember, cold air will be a lot more dense, therefore it will move a lot quicker than your warm air. The second reason why it will occur is because of the uneven surface that they move on. And the third reason would be because of differences in temperature between the surface of land and sea. Now we will look at the stages in the formation of mid-latitude cyclones. So we start off with our first stage, which is the initial stage. Now in this stage, warm, moist subtropical air meets cold, drier air along a stationary polar front. Remember, a polar front can also be called a stationary front. So just remember that. So in the diagram, we can see the warm subtropical air will be represented by a red arrow, right? And the cold polar air will be represented by a blue arrow. Now we can see that these two air masses will move parallel to each other in opposite directions, right? Obviously at the polar front, which is located at 60 degrees south or 60 degrees north. The air masses move parallel to each other in opposite directions on both sides of the front, right? This is exactly what I just said now when we were looking at the diagram. The Coriolis force will deflect both the air masses towards the left in the southern hemisphere, which is why they move parallel to each other in opposite directions. Now we look at our second stage, which is known as the wave stage. As you can see in the diagram, there is a cold front and a warm front, and you can obviously see it is in the shape of a wave. Now how do we know which is the warm front and which is the cold front? Because in your exam it will not be color coded. The warm front will obviously have semicircles along the line, and a cold front will have triangles along the line, right? That's the most simple way that you could remember that. A disturbance along a stationary front creates a wave. Now warm air begins to be uplifted by the cold air, because remember, warm air is less dense than your cold air, and your cold air will move faster than your warm air. A low pressure center begins to develop at the point where the cold and warm air masses meet. Now this is the point at which they meet, right? And at that point, a low pressure center will begin to develop. Remember, in a cyclone, the lowest pressure will be found in the center of the cell. We now look at the third stage, which is the mature stage. Now, if we look at the stage, right, in the diagram, you can see it forms a V shape. Can you see that? And we can also see two pressure readings, right? In the center, it's 1002 millibars. And then as you go outwards from there, the pressure will then increase and move on to 1004 millibars. So the cyclone intensifies as the cold and warm fronts become more distinct. Can you see they're a lot more distinct in this stage than the previous stage? So the wave deepens into a fully formed V shape, right? As I've said, you can see it will represent a V shape. The warm air rises over the cold air and the cyclone becomes more organized, forming an open wave shape. Now this is a very important point, right? Now we are discussing the weather associated with this stage. So this stage is associated with widespread cloud cover, precipitation, and strong winds. Now weather patterns may vary on either side of the fronts. Remember, because one is a warm front and one is a cold front. They both will bring different weather patterns. We now get on to the fourth stage, which is known as the occlusion stage. Now we are coming towards the end of the life of a mid-latitude cyclone, right? And in this diagram, you can see now there's an occluded front because the cold front has caught up to the warm front, right? And again, we can see that the lowest pressure will be found in the center, and this pressure is 998 millibars. Remember, pressure is recorded in millibars. So the cold front catches up to the warm front, and that is because your cold front has cold air. Cold air is dense, so it will move a lot faster. And this will lift the warm air entirely off the surface. This process creates an occluded front, where the warm air is no longer in contact with the ground and the system begins to weaken. Can you see there's an occluded front, right? There are triangles and semicircles. And heavy precipitation can occur at this stage as warm, moist air is forced to rise rapidly. We now get to the last stage, which is the dissipation stage. Now we are right at the end of the life of a mid-latitude cyclone. So as the energy source, which is the temperature contrast, weakens, the warm air is fully lifted and the cyclone loses strength. The system gradually dissipates and the weather conditions improve with fewer clouds and less precipitation. So the impact and the precautionary and management strategies very often come out as essay questions. Now each essay question will come out for about 8 marks, and that is a lot of marks, right? If you can score total in that section, then you are starting off on a very strong note, right? So let's look at the positive impacts of mid-latitude cyclones. Now these systems bring rain and snow to many regions, providing essential water for ecosystems, agriculture, and human use. In areas prone to dry conditions, the moisture from mid-latitude cyclones can be critical for replenishing soil and water reserves. So just think about this for a second. If you are living in an area that is very dry, right, your water reserves are low, the rain that comes from the mid-latitude cyclones will be extremely beneficial, not only for you, but for farmers, right? This will help them with their livestock, it will help them with their agriculture and plants. So this water that is brought in the form of rain from a mid-latitude cyclone, it will bring much needed relief to everyone in that area. The precipitation from mid-latitude cyclones helps to nourish soils and support plant growth, which is beneficial for agriculture. The rain carries nutrients into the soil, promoting healthy crops and vegetation. Right, that's just another point supporting the benefit of the rain that is brought with the mid-latitude cyclone. The strong winds and precipitation associated with mid-latitude cyclones can help clear pollutants from the atmosphere, improving air quality. This can be particularly beneficial in urban or industrial areas where air pollution is a concern. So let's say you live near a factory and that factory is constantly pumping out toxic gases into the atmosphere. The strong winds that you will get from a mid-latitude cyclone will help to blow those toxins away, and you will then have clean, fresh air to breathe. In colder regions, mid-latitude cyclones contribute to snowfall, which leads to snowpack accumulation. This snow melts during warmer months, providing a critical water source for rivers and communities downstream. Remember, once snow melts, it will become water, and that water will then run off into rivers and also fill up dams. So that's a huge positive impact, right? We now look at the negative impact, right? If you look at the diagram on the left, we can see there's flooding, there's hazardous ocean conditions, there's soil erosion, as well as damage to your cattle because of snow. The heavy rainfall associated with mid-latitude cyclones can lead to flash flooding or river floods, particularly in low-lying or poorly drained areas. This can cause significant damage to homes, roads, and farmland, displacing people and disrupting communities. Remember, floods can damage your home, can damage all your furniture. People can even drown because of this flooding. Prolonged storms, flooding, and extreme cold associated with mid-latitude cyclones can cause significant damage to crops and livestock. Heavy rains may lead to waterlogging, and snow or ice can harm crops. Livestock may also be affected by severe weather conditions and freezing temperatures. Remember, certain animals are not used to these cold temperatures, and once they are exposed to this, they can die, and that will cause a massive loss to farmers and the community. Soil erosion occurs from the heavy rains and will damage the environment. Mid-latitude cyclones create rough seas characterized by large waves, strong winds, and dangerous currents. These conditions can be hazardous for ships and maritime operations, leading to the capsizing of smaller vessels and delays of ships, affecting global shipping and supply chains. Increased risk of accidents, particularly in fishing and transport industries. These storms can also endanger the lives of sailors and fishermen, requiring them to avoid affected areas or seek shelter. Now, a lot of people rely on fishing, right, to bring in an income for them and their families. And if there are hazardous conditions out at sea, they won't be able to go there because obviously their boat can capsize and they will lose their lives. So the hazardous conditions out at sea will be a very negative impact. Now we will look at the precautionary and management strategies, right? Obviously, these can also be asked in an essay form, and you would have to give 8 strategies and obviously explain each strategy. So today I'm going to be giving you 9, as that will definitely give you more than enough, right? And they all are simple, so they are easy to remember. So our first strategy is houses should not be built in low-lying areas as they will be affected by floods. Can you see? It's simple, easy to remember. The second strategy, an efficient drainage system should be implemented in urban areas as this will reduce the risks of flooding. Strategy 3. Sheep and other livestock must be placed in a kraal or shed in order to keep them safe. Number 4. Farmers should keep sufficient feed for the livestock in order to avoid livestock losses. Number 5. Always monitor weather patterns and conditions before going on any outdoor adventures. Now, outdoor adventures, they're not only referring to hiking, they're also referring to activities that can be as simple as going to the store. Right? That can be dangerous if there's a mid-latitude cyclone coming. Strategy 6. Remain indoors during hazardous conditions. So if you see there are large grey clouds, if you see there's heavy winds, then please remain indoors. Number 7. Stock up on all essentials such as batteries, food, and medication. Number 8. Building and maintaining sea walls, levees, and storm surge barriers in vulnerable coastal areas can help protect against flooding and storm surges. Now, number 9. identifying and zoning high-risk flood areas can prevent construction in vulnerable regions and reduce potential damage. Properties in flood zones may require elevated foundations or other flood-proofing measures. So those are basically all 9. Like I said, you are welcome to take a screenshot and write them down in your book and constantly go over them each and every single day. So when you get to your exam, you automatically remember all 9 and you can easily write it down in the form of an essay. Did you know that the tropical cyclone section in your exam paper typically comprises of about 15 marks? So today we're going to be looking at the characteristics, the conditions necessary for formation, the stages and effects of tropical cyclones. We're also going to be going over essay question tips. So first we're going to be looking at the general characteristics of tropical cyclones. So tropical cyclones form over warm ocean waters, typically between 5 degrees and 20 degrees latitude in both hemispheres. They require sea surface temperatures of at least 27 degrees Celsius to develop. And I'll explain to you exactly why that is so once we get to the conditions necessary for formation. High humidity in the atmosphere is crucial for their formation, particularly in the lower and middle troposphere. Tropical cyclones typically last from a few days to several weeks depending on environmental conditions. Now that's very important because that can be asked. They will ask, how long do tropical cyclones typically last for? They move from east to west and they are steered by the easterlies. So if they ask you what direction will tropical cyclones move in, you will say they will move from east to west, or you can say they will move in a westerly direction. They average between 300 and 500 kilometers in diameter, with the eye being plus minus 30 kilometers in diameter. Now again, that's also very important because that will indicate the size of the entire cyclone and the eye. So our first condition that is necessary for formation will be sea surface temperatures must be at least 26.5 degrees Celsius or higher, which provides the energy needed for the cyclone to form and intensify. The warm ocean water evaporates, adding moisture to the air, which fuels the storm. Now, moisture is very important for the storm, right? That is why you have to have an ocean temperature of at least 26.5 degrees Celsius. The next condition will be the atmosphere must be unstable, meaning warm, moist air near the surface rises and cools as it moves upwards. This rising air helps generate the towering thunderstorms needed to sustain a cyclone. Tropical cyclones form between 5 degrees and 25 degrees latitude in both hemispheres because the Coriolis effect. Now, the Coriolis effect is the deflection of moving objects caused by the Earth's rotation, right? So this is necessary to create the cyclone spin. Near the equator, the Coriolis effect is too weak for cyclones to develop. Therefore, it has to develop between 5 degrees and 25 degrees latitude in both hemispheres, right? Number 4, there must be high humidity, which is moisture in the air, in the mid to lower levels of the troposphere. This is the layer of the atmosphere that is closest to the Earth's surface. This moist air is important for the formation of clouds and thunderstorms within the cyclone. Now we get to the stages, right? And our first stage is known as the initial stage. So, pressure is above 1000 millibars at the center in this stage. So let's look at the diagram quickly, right? We can see that this is a low pressure system. How do we know? We can see that the lowest pressure will be found in the center, right? And that will be above 1000 millibars. Its exact number is 1004 millibars. And we can see as you go outwards, the pressure will increase. Now these arrows, these orange arrows, will represent the flow of air, right? And whenever you see arrows flowing into a low pressure cell, that is known as convergence, right? Convergence is the movement of air into a low pressure cell. So let's look at our second point. There is a big distance between isobars. Can you see that's a very large distance between the isobars? Now the distance between your isobars is basically your pressure gradient. So if there's a larger distance, there's a more gentle gradient, right? Same thing with map work. When warm air converges towards the center of the storm, an eye forms. So light rain occurs and gale force winds occur up to 50 kilometers from the eye. We now look at the second stage, which is known as the immature stage. So in this stage, the pressure at the center will drop below 1000 millibars. Let's look at our diagram here. Now we can see that in the center, there's an eye that has formed. We can see that the pressure at the center is well below 1000 millibars. It is actually 980 millibars. Remember, in a cyclone, which is a low pressure cell, the lowest pressure will always be found in the center. And we can see again, these arrows will represent the movement of air as it converges into the low pressure cell. So as the air continues to converge into the center, the eye intensifies. As you can see, that is the eye right there. Now in this stage, hurricane strength winds will occur. The diameter is 100 kilometers, right? That's also very important to know. And in this stage, which is the immature stage, cumulonimbus clouds can be found around the eye. Now we get to the third stage, which is known as the mature stage. Now we can see a lot is happening in this diagram. So let's look at the point and let's get back to the diagram. So the pressure at the center is well below 1000 millibars and it will remain at that reading. Can you see it's at 982 millibars? Now in the center, you can see the eye is a lot more defined. We can see there is a very small distance between the isobars, and we can see the presence of a dangerous quadrant. A steep pressure gradient is indicated by isobars that are located close to each other. Can you see how close they are? So the closer they are, the steeper the pressure gradient. So the diameter is 300 kilometers to 500 kilometers. Right now, the tropical cyclone is in its peak at this stage, in the mature stage. So you may be wondering, what is the dangerous quadrant? The dangerous quadrant will experience the most severe conditions. So within the dangerous quadrant, you will have the most severe weather conditions. So you can have torrential rain, you can have heavy winds, you can have hail, there's thunderstorms. All of that will be found in its most severe form in the dangerous quadrant. Massive cumulonimbus clouds form around the eye. And again, in the mature stage, the wind speed is more than 120 kilometers an hour. Now we get to the last stage, which is known as the dissipating stage. Now this is the end of the tropical cyclone's life. So the tropical cyclone will begin to dissipate once the pressure rises above 1000 millibars. Now there are many reasons why a cyclone will dissipate, and today we're going to be looking at three causes, right? There's three causes of dissipation. So the first cause of dissipation will be when a tropical cyclone moves over land, it loses its main energy source, which is warm ocean water, right? Friction from the land also disrupts the airflow, weakening the storm. The second cause of dissipation is moving over colder ocean waters, because remember, you have to have a minimum of 26.5 degrees. So once the ocean waters drop to below 26.5 degrees Celsius, it reduces the energy available to the storm, and this will cause it to weaken. Now, high vertical wind shear can distort the cyclone structure. This will pull apart its core and inhibit further development. Now I want to go through the weather that is associated with tropical cyclones. So as a cyclone will approach, there will be a wind speed of more than 120 kilometers an hour, right? There will be heavy rain, there will be hail, lightning, and thunder, right? Remember, this is as the cyclone will approach. We then look at the weather that is found in the eye, right, in the center. This will be calm conditions, there will be no rain, and the lowest pressure will be found in the center. So why is that? This is because the upward spiraling movement of air will create an artificial wall around the center. Now that wall will prevent any surface air from rising and cooling, and because of that there will be no condensation that will occur, and if there's no condensation occurring, then there will be no clouds or rain produced. right? And as the cyclone moves away, the weather conditions will be the same as when the cyclone is approaching. So basically they will have very high wind speeds, there will be heavy rain, hail, lightning and thunder. So I hope this diagram makes it a lot easier for you to understand. So now we're looking at the effects of tropical cyclones. Now this can come out in the form of an essay. What you can do is you can take a screenshot of the screen, obviously, as we're going through the effects. And when you're writing it down in a notebook or on an exam pad, write it down in the form of an essay and memorize that essay. So when you go into writing your exam paper, you know exactly, okay, cool, this is how I answer this essay question. And like that, you can ensure that you get total in that section. So the first effect will be strong winds, right? Now wind speeds in a tropical cyclone can exceed 250 kilometers an hour in the most powerful storms. These winds can cause damage to buildings, homes and infrastructure like power lines, bridges and roads. These winds can also cause the uprooting of trees and the destruction of forests. There will be widespread power outages and flying debris can be life-threatening. As you can see in the diagram, there are a lot of uprooted trees and these trees can fall on homes. And if you are sitting in a room and the roof caves in, then obviously that's going to be life-threatening. The next effect will be heavy rainfall. Now tropical cyclones bring torrential rains that can lead to flash floods in urban and rural areas. There will be overflowing of rivers and lakes causing large-scale inundation. There will also be waterlogging of crops and agricultural fields, which will lead to crop destruction. Next, we can see storm surge. So this is the abnormal rise in sea level caused by strong winds pushing seaward water towards the coast. Storm surges can flood coastal areas leading to severe damage to homes and infrastructure. It can erode coastlines and destroy natural barriers like dunes and mangroves. It can also contaminate freshwater supplies with salt water. So what are the economic impacts of tropical cyclones? Not many people speak about this, right? So rebuilding after a cyclone is extremely costly. Governments, businesses, and individuals may struggle with long-term financial recovery. Damage to critical infrastructure such as roads, power lines, hospitals, and schools can take months or even years to repair. The economic cost to agriculture and industry often runs into billions of dollars, or in our case, rands. And the loss of tourism in tropical regions can severely affect local economies. The next effect will be environmental degradation. Coastal ecosystems such as coral reefs, mangroves, and wetlands can be damaged or destroyed by cyclones. This can lead to long-term changes in marine and coastal biodiversity. Soil erosion and salinization of agricultural lands can affect farming and food production for years. Now, what are some management strategies, right? How can you manage the effects of tropical cyclones? Firstly, you can implement early warning systems. So these are weather forecasting and monitoring, right? Meteorological agencies can use satellite images, weather radars, and computer models to track and predict cyclones. Early warnings can help authorities and communities prepare for the storm's arrival. They can also issue cyclone alerts. So public alerts and notifications should be issued well in advance, characterizing the cyclone's potential severity. Example, watch, warning, or emergency. Flood defenses and storm surge barriers, right? So construction of levees, sea walls, and storm surge barriers can protect coastal areas from flooding caused by storm surges. Another very important management strategy is supplies, right? So people should buy and stock up on essentials such as canned foods and water, because obviously during a tropical cyclone, you're not able to leave your home. So you're going to need canned food and water in your home to last a long time. People should also purchase medical kits. The next strategy is cattle safety. Remember, cattle should be either moved to higher ground or kept in safe structures such as kraals or sheds. If a farmer is going to leave his cattle out, then they all are going to get killed and it's going to be a major loss for him and the community. There needs to be pre-planned evacuation routes. Authorities should establish and communicate evacuation routes and shelters in cyclone-prone areas. Communities should also be trained on evacuation procedures with drills conducted regularly, right? This can really help to save lives. You can also implement search and rescue operations, right? Immediate deployment of trained rescue teams to areas affected by the cyclone to assist trapped or injured people. The use of helicopters, boats, and other emergency vehicles to reach flooded or isolated areas. Because remember, during a cyclone, roads will be flooded, so you're going to have to use helicopters in order to go to isolated areas. So if I had to ask you to analyze this weather station and give me various conditions such as your wind speed, wind direction, and cloud cover, what would you do? So this is a weather station. So let's analyze this weather station from the right hand side. So first we can see there are two numbers here. The number on top, which is 28 degrees Celsius, is basically the air temperature. Now, when we talk about the temperature outside, let's say, oh, it's very hot today. We are referring to this temperature here, and it will always be the number at the top. Now, the number at the bottom will be your dew point temperature. Your dew point temperature basically just gives you more information about humidity. The most important things to remember is that air temperature will be the number at the top and dew point temperature will be the number at the bottom. Next we can see this circle. So this circle will basically give you the cloud coverage at an area, right? And we can see that this circle is partially shaded. So half this circle is shaded in. So what does that mean? That actually means that there is 1/2, which is half, cloud coverage. Remember, there are 6 different types of cloud coverage that you can get, right? And I'm going to be going in depth into them once we're done with this small example. It is very important to know the different types of cloud coverage and precipitation symbols that you can get, because if the examiner switches it up and gives you a very random one, you have to know exactly what you're looking at. So this cloud coverage will basically indicate that there is a half cloud coverage, right? So next, let's look at this long line here. Now this line will actually show you the direction of the wind. A lot of students make the mistake of looking at these two small lines here and saying that that will indicate the direction. That does not indicate the direction. That will actually show you the wind speed. So let's get back to this long line here. Now, we can see that if we draw a simple compass, right, I'm going to be showing you exactly how to remember this once we're done with this example. So what do we say this direction actually is? Do we say it is west-north? No. North will take dominance over west. So this will be north-westerly. So if we had to say the direction of this wind, it will be northwesterly. westerly. So next, let's look at this small symbol here. We can see it is just a dot. Now, this symbol that you will find next to the bigger circle will give you an idea as to what the precipitation is like, right? So a simple dot will represent rain, right? Just normal rain. So if you see a dot, just know it will symbolize rain. Now, lastly, we will look at these two lines. As you can see, these are two long lines, right? So what does this mean? A long line will represent 10 knots. Remember, the unit of measurement for wind speed will be in knots, right? And a shorter line will represent 5 knots. And if you can see that in this example, there are just two long lines, that means that the wind speed will in fact be 20 knots an hour, right? That is a unit of measurement for speed, wind speed. So now let's go a bit deeper and look at the different symbols and different cloud cover. So here we have these 6 different types of symbols that you can find on a synoptic weather map. So let us look at the first one. So here we can see there are 3 parallel lines, right? And this will basically indicate, right, if you see this symbol, it will indicate that there is fog in that area. So if you see this symbol here, the precipitation will be fog. And then we can see the next symbol. It kind of looks like an inverted comma, right, if you really look at it. And this will basically indicate that there is drizzle in that area. Now remember, drizzle will be light rain. So the next symbol is a dot, right? And this will indicate rain, as we know from our previous example. Then we can see the symbol, which basically looks sort of like a snowflake, right? And this will indicate that there is snow. Now this next symbol will basically indicate that there are showers in that area. Now showers is basically heavy rain, right? So this will be showers. And for your last symbol, it is a very complicated looking symbol. But if you break it down, it's basically like a letter T with a crooked arrow. That's basically how to draw it, right? And this will represent thunderstorms. So there are the 6, right? Let's go over them one more time. So if the examiner had to ask you for the type of precipitation at an area, you will look at your weather station and you will decipher which symbol is displayed there. So if you see 3 parallel lines, that will give you fog. If you see an inverted comma, that will give you drizzle. If you see a dot, that will give you rain. If you see a snowflake or an asterisk, that will mean snow. If you see an upside down triangle, it will be showers. And if you see this complicated sign, let's say it's a T with a crooked arrow, it will mean that there are thunderstorms in that area. So the next thing that we're going to be looking at will be cloud cover, right? There are six different types of cloud cover that you will find. So as you can see, these are the 6 different types of cloud cover that you can get. So let us start on this side. As we can see, this circle is fully shaded in. So that will represent overcast conditions. So if you see a circle that is fully shaded in, that should be overcast conditions, right? It'll be overcast conditions. Then we see a circle which 3 of the 4 parts are shaded in, so 3/4. That will represent 3/4 cloud coverage. So your answer can look like this, right? 3 out of 4 and just say cloud. You can say cloud coverage if you want to, or cloud cover, but I would just put 3/4 cloud, right? And now we can see only half the circle is shaded in. So that will represent 1/2 cloud. So half cloud coverage, right? Now we can see another circle in which there's only 1/4 that is shaded in. So that will give us 1/4 cloud, right? So it's 1/4 cloud coverage. And now this circle is quite interesting because we can see there's only a small dot that is colored in, right? There's only a small dot that's shaded. So what will this represent? This will represent 1/8 cloud, right? So 1/8 will be your cloud coverage for this example. And then we can see a circle that is not colored in at all. It is completely clear. And that will basically represent clear conditions, right? Clear skies. So you can just say clear. So that is it. It's extremely simple. Let us go over it one more time. So we can see a fully shaded in circle will represent overcast conditions. A circle in which 3 of the 4 parts are shaded in will represent 3/4 cloud cover. A circle in which there's only half that is shaded in will be 1/2 cloud coverage. If there's only one part of the circle that is shaded, it will be 1/4 cloud coverage. If you see just a tiny small dot that is shaded in, that will be 1/8 cloud cover. And if you see a circle in which it is completely empty, that will mean clear conditions. So let us do just one more example so that we can make sure that we are fully covered. So if the examiner will ask you any type of question, you'll be ready for that question. So let us do that now. So let's take a look at this example. So now, first we can see these two different numbers here. Remember, the first one will be your air temperature, and that will be an air temperature, right? Let's just write down air temperature. Remember, this T with a degree there will mean temperature, right? T with a degree will mean temperature. So if you ever see that, just remember that that will represent temperature. So this will be your air temperature, and the number at the bottom will be the dew point temperature, right? Your dew point temperature. Now in the circle, we can see that there's only a small circle that is shaded in that, right? So what does that mean? So we can see that there's just a small circle that is shaded in. So that will represent 1/8 cloud, right? Remember, as long as you only see a small circle that is shaded in, that will be 1/8. Next, we can see an upside down triangle for a precipitation, right? And this will basically present showers. So the precipitation in this area will be showers, right? Let's say showers. So now this long line will represent the wind directions. So what is an easy way to remember how to draw a simple compass? Right now, I don't know if you guys have watched Harry Potter before, but if you have, then you know he has a lightning bolt scar, right? Now a compass will basically, if you had to write the letters of a compass out, it will spell the word news. So just remember the word news and Harry Potter scar. So all you do is north, east, west, south. And if you draw it out like that, it will be north, east, west, and south, right? Let us just erase this part. So as you can see, north, east, west, south. Now the thing is, there are 4 extra degrees that come into play, right? One will come from here, one will come from here, another one will come from here, and your last one will be from here. Now, what you need to know is that north will take dominance over west and east. South will take dominance over east and west as well. So if we're looking at the angle that falls between north and west, we can say it is northwesterly. If we're looking at the angle that falls between north and east, we say that is northeasterly, right? If it falls between south and east, we can say it is southeasterly. And if it falls between south and west, we can see it is southwesterly. So since this line here falls between south and west, south will take dominance over west, and the direction will be southwesterly, right? There's an easy way to remember that. And lastly, we can see these 2 lines. Remember, these will represent your wind speed. So if there is one long line and if there's one short line, the longer line will represent 10 knots and the shorter line will represent 5 knots. So that will be a total of 15 knots. Now remember, your answer has to be in the form of knots per hour. So we can say 15 knots per hour. And that's it. Nothing too complicated, simple and easy.
So here's how to identify whether a synoptic weather map is going to be displaying summer or winter conditions. Now, in order to identify a summer map, you're going to look for a heat low or a thermal low over the interior. Now, this is obviously going to be a low pressure system that's going to be found over the central interior. And you're going to look for a capital letter L over the interior of South Africa. Now remember, this is going to be one of the easiest signs that this map is going to represent your summer conditions. Secondly, you're going to look for your tropical cyclones. Now these can appear to the east of South Africa, obviously over the Indian Ocean. Because remember, during summer, your ocean temperatures are going to be at its highest. And that's going to provide the energy for your tropical cyclone to develop. Now as you can see on this synoptic weather map, you're not going to see a tropical cyclone. Which means that if this map were to appear in your exam, you would obviously need to look for other visual clues in order to truly know that it is a summer synoptic weather map. So the next visual clue would be high temperatures. So your weather station models, they are going to show high temperatures. Remember, your summer synoptic weather maps, they are going to display much higher temperatures than obviously your winter maps. So if we had to zoom in and take a look at these weather station models, you will see that the temperatures are approaching 30 degrees Celsius, and we will have one that's going to be exceeding the 30 degrees Celsius mark. Which again further proves that this is going to be a summer synoptic weather map. The next clue would be convective rainfall or thunderstorms. Remember, on a summer map, when you take a look at your weather station models, some of them will be displaying the thunderstorm symbol. So this is going to be the symbol that we are talking about. And your last major clue would be the South Indian High and your South Atlantic High. They are going to move southward, which means they're going to move away from land. Now, as we know, during summer, these two high pressure systems, they are going to shift further southward. So if you are able to see most of these visual clues on a synoptic weather map, there's going to be a very high chance that that map will be displaying summer conditions. Now, in order to identify a winter map, you're going to firstly look for your Kalahari or your continental high over the interior. So what you're going to look for is a capital letter H over the interior of the country. So basically, if you see a capital letter H over the interior of the country, that's going to be your Kalahari high or your continental high. Secondly, you're going to look for your cold front that's going to be approaching or crossing South Africa. Now this is also going to be one of the easiest clues to look out for, and you might find your cold front being in line with the Western Cape. Next, you're going to look for your mid-latitude cyclones, and that's because obviously they're going to be common during winter, right? So if you're going to see your warm and your cold fronts, that's going to represent your mid-latitude cyclone. Another major clue would be your high pressure cells. They are going to be more dominant during winter. So your South Atlantic high and your South Indian high, they are going to be well developed. And during winter, they're going to move northward, which means they're going to move towards land. So if you see your South Atlantic high and your South Indian high being close to land, that's going to be a very strong indication that this map is going to be a winter map. And lastly, you're going to look for your low temperatures. So your weather station models, they are going to show cooler temperatures. And if we were to look at these weather station models, you will see the temperatures being 15 degrees, 20 degrees, and 17 degrees. And again, if we are going to see all or most of these visual clues present, then there's going to be a very strong chance that this map is going to be a winter map. So today we're going to be quickly looking at your high pressure systems, which are also going to be known as your anticyclones. Now, a lot of students tend to confuse this with cyclones, so just remember that a high pressure system is going to be known as an anticyclone, and a low pressure system is going to be known as a cyclone. So what are anticyclones? A high pressure system or an anticyclone is an area where air pressure is higher than the surrounding areas. So in other words, right, the atmosphere in that region is going to be exerting much more force on the Earth's surface compared to your nearby areas. Now within an anticyclone, your air is going to sink from your upper atmosphere, and as this air is going to sink, it's going to compress and it's going to warm up. And this is what's going to prevent your cloud formation. And as a result of that, your anticyclones are going to be associated with clear skies, dry weather, stable conditions, and light winds. Now there are going to be three major anticyclones that are going to affect South Africa. The first being the South Atlantic High to the west, the second being the South Indian High to the east, and the third being the Kalahari High over the interior of South Africa. So let's start with the South Atlantic High. So the South Atlantic High, also known as the St. Helena High, is a semi-permanent high-pressure system located over the South Atlantic Ocean to the west of South Africa. It forms part of the subtropical high-pressure belt, which shifts north and south with the movement of the sun. Now from this point, we are given two very important pieces of information, right? So firstly, when we mention semi-permanent, we actually mean that the cell is always going to be present, right? But it is going to shift slightly during summer and during winter. Now we will discuss this in detail later on. So then we said it's going to be located over the South Atlantic Ocean, which means that the cold Benguela current is going to be present. Now because your cold Benguela current is going to be present, it means that the ocean is going to be cold. And because it's going to be a cold ocean, there's going to be so much more subsiding air, because remember, cold air is going to be much more dense than warm air, so it will sink. And that's basically going to mean that your South Atlantic High is going to be your strongest anticyclone because there's going to be so much of subsiding air. Now in terms of air circulation within the southern hemisphere, your air is going to circulate anti-clockwise around the high. The air is going to sink at the center, and your air is going to diverge outward at the surface. And remember, because you're going to have air that's sinking, your cloud formation is going to be limited, right? Because sinking air is going to prevent cloud formation, and therefore your rainfall is going to be very low. Remember, if there's no cloud formation, there's not going to be any rain. Now in terms of weather conditions, your South Atlantic High is going to be associated with clear skies, dry and stable conditions, especially along the west coast in areas such as the Namib Desert. There's going to be little to no rainfall, and you're going to have light winds. So remember, we said that the cold Benguela current is going to be present, right? Now this cold current is going to cool the air above it, right? And that's going to create a stable atmospheric condition, which is going to reduce evaporation. And the result of that is going to be very low rainfall along your west coast. So that's why places like your Namib Desert are going to be so dry. Now one last thing is that in terms of precipitation, even though your rainfall is going to be very limited, you're still going to have fog and you're going to have mist that can occur along the west coast. Now in terms of the position of your South Atlantic High during summer and winter, it is going to be a semi-permanent cell, which means that it's going to be present, but it's going to change with your seasons. During summer, it's going to shift southward, which is away from South Africa, and this is going to allow your moist air from your Indian Ocean to move inland, and this is then going to contribute to your summer rainfall in the interior of the country. Now in winter, it's going to shift northward, which is closer to South Africa, and this is going to allow your cold fronts to affect the southwestern Cape. Now in terms of ridging of the South Atlantic High, basically ridging is going to occur when your South Atlantic High is going to extend along your south coast of South Africa. Now the process of ridging is going to look something like this. Firstly, you're going to have a mid-latitude cyclone that's going to pass over the southern part of South Africa. Then you're going to have your cold front, which is going to move away. And as the cold front is going to move away, your South Atlantic High is going to move in behind it. And that's going to cause this high to extend along the coastline, right? And this extension is going to be called ridging. Now during ridging, you're going to have cool conditions, you're going to have strong winds, you're going to have cloudy skies, and ridging can even cause coastal rainfall, right? Along the southern Cape, along the eastern Cape. And that's because your winds are going to blow from the ocean towards the land. So now we're going to look at the South Indian High. Now, the South Indian High, which is also going to be known as the Mauritius High, is a semi-permanent high pressure system located over the Indian Ocean east of South Africa, and it will form part of the subtropical high pressure belt. Now remember, because your South Indian High is going to form over the Indian Ocean, it means that your warm Mozambique current is going to be present. And because of that, your South Indian High is going to be weaker than your South Atlantic High, because there is going to be less subsiding air. Now again, during summer, your South Indian High is going to shift southward, which means that it's going to move away from South Africa. And because your South Indian High is going to move away from South Africa, it's going to allow moist air from your Indian Ocean to move inland. And this is then going to warm temperatures over the interior. You will then also have your rising air due to your heating. The result of all of this is going to be thunderstorms over the interior. And this is exactly why most of South Africa is going to receive summer rainfall. Now during winter, your South Indian High is going to shift northward, which means it's going to move closer to land. And because it's going to move closer to South Africa, your winds are going to travel a much shorter distance over the ocean, and therefore they are going to carry less moisture. And you need to remember that at the same time, the interior of the country is going to be dominated by the Kalahari High. And the result of all of this is going to be dry conditions over most of South Africa. Now what is a blocking high? Now a blocking high is going to occur when a high pressure system is going to become strong and it's going to become stationary, right? So it's basically going to remain in one place for a long time. So what are the effects of a blocking high? Now when your South Indian High is going to act as a blocking high, your weather systems like your mid-latitude cyclones are going to be blocked. And this means that they are not going to be able to move normally. And all of this is going to cause persistent weather conditions, it's going to cause extended dry periods, or it can cause prolonged rainfall in some areas. Then we're going to get to your Kalahari High, which is also known as your continental high. So the Kalahari High is a continental high pressure system that develops over the interior of southern Africa. It's going to be called a continental high because it's going to form over land, not over the ocean. Now because your Kalahari High is going to form over land, not the ocean, it's going to mean that your Kalahari High, it's not going to be so strong, right? It's going to be the weakest cyclone of the three. Basically, your South Indian High and your South Atlantic High are going to be stronger than your Kalahari High. Now the Kalahari High is going to be centered over the Kalahari Desert and it's going to affect the interior plateau of South Africa. Now remember, the Kalahari High is going to be its strongest in winter, and this is going to cause clear skies, dry conditions, cold nights which will result in frost, and you can have a stable atmosphere. In terms of precipitation, there's going to be little to no rainfall over the interior, and again that's going to be because your air is going to be sinking, which is going to prevent cloud formation. Now in summer, your interior is going to heat up, your air is going to begin to rise, and your Kalahari High is going to weaken, which will then allow your moist tropical air to move inland, which will lead to summer rainfall. Now, if you just want a quick summary before your test, here's going to be a nice table that's going to summarize all the differences between your South Atlantic High, the South Indian High, and your Kalahari High. So feel free to pause the video and read this, or take a screenshot and keep it for later. Now this is going to be table 1. And this is going to be table 2. So let's quickly go over all the factors that will influence the weather and climate of South Africa. So South Africa's weather and climate are mainly going to be influenced by 3 things: the plateau, the oceans, and latitude. So starting off with the plateau, the interior of South Africa consists of a high plateau, which is an extensive high-lying area that is thousands of square kilometers long and averaging between 1,000 and 2,000 meters above sea level. Now remember, because the plateau is going to be so high above sea level, it's going to directly affect South Africa's temperature and the rainfall patterns. So in terms of characteristics, your temperatures are going to decrease with altitude. So this means that as your height is going to increase, obviously your air is going to become thinner and it's going to be colder. And this is basically why your high-lying areas are going to be so much colder than your low-lying coastal areas. The plateau is going to experience cooler temperatures than your coastal areas at the same latitude. Now keep in mind, places like Johannesburg and Durban, they are going to be at the same latitude. But Johannesburg is going to be so much cooler because it's much higher above sea level. The escarpment acts as a barrier to your moist air from the oceans. So think of your escarpment as a wall, right? The moist air that's going to be coming from your ocean, it's not going to be able to move deep into the interior because you're going to have this wall that's going to block it. And this is then going to reduce your rainfall inland. Now don't stress about that too much because we will be discussing it shortly. Now in terms of the influence of the plateau on weather and climate, the interior of the country is going to experience hot summers and cold winters. Now keep in mind, in the interior of the country, there's not going to be a strong ocean influence, right? So that means that your temperatures, they're going to vary a lot between seasons. So in summer it's going to be very hot and in winter it's going to be very cold. Frost is going to be common during winter in many inland areas because remember during winter your temperatures are going to drop, very low. It's going to drop low enough for your frost to be able to form. Moist air from the Indian Ocean rises along the escarpment, cools and condenses, causing rainfall on the eastern slopes. Areas on the leeward side experience a rain shadow effect and receive less rainfall. Now let's take a better look at this diagram. So the left hand side of this diagram is going to be representing summer, whereas the right hand side is going to be representing winter. So during summer the Kalahari High becomes weak because of your high temperatures over the interior. So if we're saying that your Kalahari High weakens, in summer it's now going to be less dominant, right? And that's because the air is not going to be sinking as strongly as it is in winter. Subsiding air over the interior is weaker, allowing the inversion layer to rise above the escarpment. Remember, we're now going to be having a weak subsidence. So that means that we're going to have weaker sinking air. And this is now going to allow that inversion layer to be pushed up higher into the atmosphere. And it literally rises above the escarpment. And this is going to mean that it's no longer going to block the moisture coming from the ocean. Because the inversion layer is high up, the door is wide open. So warm, moist air from the Indian Ocean is now able to move across the escarpment and spread onto the plateau. Remember, your inversion layer is going to act like a barrier. It's going to act like maybe a door or a wall. And once this barrier is now going to be lifted, all of your warm and your moist air, which is going to be coming from the Indian Ocean, can now move inland. And it's going to travel over the escarpment and it's going to spread, across your interior plateau. And as a result, most of the interior is going to receive widespread summer rainfall. And that's why most of South Africa's interior is going to get summer rainfall, because of this moist air that's able to move deep inland and form thunderstorms. Now if you're taking a look at the right hand side, the Kalahari High is going to become strong as your interior cools significantly. Now because during winter your land surface is going to cool down so rapidly, this is now going to strengthen your Kalahari High, right? So that means that you're going to have more stable sinking air, which is now going to dominate the interior of the country. So you're going to have strong sinking air developing over the interior, which is going to cause your inversion layer to form below your escarpment. So if you can have strong subsiding air, we can have a strong subsidence. And this is going to cause that inversion layer to form much lower in the atmosphere as compared to summer, which you can see on the left. Moist air from your Indian Ocean is blocked from reaching the plateau because of your lower inversion layer. Now if you take a look at your diagram, you will see that the inversion layer is now going to be so low, it's literally going to act as a barrier. And this means that the moist air which is going to be coming from your Indian Ocean, it's not going to be able to rise above your inversion layer. So all of this moist air is going to be blocked from reaching your interior plateau. Now, as a result of this, the interior is going to experience little or no rainfall, with clear, dry and stable weather dominating throughout winter. And this is why, winter in the interior of the country is going to be dry and it's going to be stable. You're going to have, very little cloud formation and you will have clear skies. So next we're going to be looking at the oceans. So South Africa is going to be surrounded by two oceans. You're going to have your Atlantic Ocean along the west coast, and it is going to be influenced by your cold Benguela current. You're going to have your Indian Ocean, which is going to be found along your east coast, and it's going to be influenced by the warm Mozambique current. So let's first look at the cold Benguela current. So this is going to be a cold ocean current flowing northwards along the west coast. Now the cold Benguela current is going to bring cold water from the south, right? And this is now going to cool the air above it. You're going to have low evaporation rates, and remember, this is going to be because the water is going to be cold, right? So if you can have cold water, you can have very little evaporation, right? And that means that there is going to be very little moisture, which is going to be available for rainfall. Now, in terms of the effects of your cold Benguela current on weather and climate, firstly, it is going to produce cool and dry conditions. It is going to reduce your cloud formation and rainfall. It contributes to the arid conditions of the Namib Desert and your western South Africa. It often causes fog along the west coast. Remember, the air over your Atlantic Ocean is going to be dry, right? And that dry air is going to contribute to your desert conditions along your west coast, just like we mentioned just now. Now, in terms of the influence of your warm Mozambique current, you're going to have your warm ocean current flowing southwards along the east coast. Remember, if this current is going to be carrying your warm tropical water, it means that it will heat the air above it. And you will then have high evaporation rates, because remember, warm water is going to evaporate easily. That means there's going to be a lot of moisture in the atmosphere, which will lead to high humidity. So in terms of the effects on weather and climate, it is going to increase the moisture in the atmosphere. Remember, if we can have a lot of water vapor in the air, conditions are going to be very humid. It promotes cloud formation and rainfall. It results in warm and humid conditions along the east coast. And your moist air over the Indian Ocean brings high rainfall to the eastern half of the country. And thirdly, we will be looking at latitude. So latitude refers to the distance of a place north or south of the equator. Now, this is going to be very important, because remember, the closer you are to the equator, the warmer it is going to be. So South Africa lies between approximately 22 degrees south and 35 degrees south. So that means that the country is going to be located in the subtropical zone. So we are going to experience, your warm conditions. And remember, because South Africa lies along your 30 degrees south latitude, that's going to be where your subtropical high pressure zone is going to be located. Now remember, in that zone, we're going to have sinking air, and we're going to have your stable and your dry weather conditions. So keep in mind, this pressure zone that we're talking about, it's going to be broken up into three high pressure zones. You're going to have your South Atlantic high, you can have your South Indian high, and you're going to have your continental high. So in terms of its influence on weather and climate, areas closer to the equator are going to be generally warmer. Now that's because they are going to receive direct sunlight. Temperature decreases from north to south, because remember, the northern part of South Africa is going to be closer to the equator, so it will be warmer. Northern South Africa experiences higher average temperatures than the southern areas. Latitude influences the angle of the sun's rays and the amount of solar energy received. Divergence and subsidence occurs in these high pressure cells, resulting in generally stable weather conditions. Sinking air warms up adiabatically, creating desert conditions which will be dry. And remember, this is going to be one of the reasons as to why your Kalahari Desert is going to be present. That's going to be where the center of your continental high is going to be located. So let's quickly go through moisture fronts and line thunderstorms. A moisture front is going to be the boundary between your two air masses with different moisture content. So you're going to have your warm, moist, humid air coming from your Indian Ocean, and you're going to have your cold, dry air, which is going to be coming from your Atlantic Ocean. Now when these two air masses are going to meet, your lighter air, which is going to be your moist air, it is going to be forced to rise, right? Now this is going to lead to your cloud formation and rainfall. So in terms of characteristics of a moisture front, firstly, it is going to be a boundary between your moist and your dry air. So it's going to separate your humid air from your dry air, and it's often going to be found over the interior of South Africa during summer. Secondly, there's not going to be a significant temperature difference. So unlike a cold front, a moisture front is mainly identified by differences in moisture content rather than temperature. Now keep in mind, you are going to have your slight differences in temperature, but obviously your main feature is going to be the difference in humidity, right? So one air mass is going to have a lot of moisture while your other one is going to be dry. Thirdly, it is going to cause rising air. So your moist air rises when it meets your denser dry air, and this rising air is going to cool and it's going to condense. So basically your warm moist air, it's going to be lifted upwards, it's then going to expand and cool down, and once it cools down to your dew point temperature, obviously condensation is going to occur and your clouds are going to begin to form. You're going to have cloud formation, so large cumulonimbus clouds may develop. So keep in mind, your cumulonimbus clouds, they are often going to be associated with heavy rainfall, lightning, thunder, hail, and very strong winds. Just like this next point states, your moisture front is going to be associated with thunderstorms. It frequently produces afternoon thunderstorms in summer. And these thunderstorms are going to bring heavy rain, hail, lightning, strong winds, and in some cases, flash flooding. And lastly, it is going to be common in summer. Because remember, in summer, the interior of South Africa is going to become very hot. And this will then, attract your warm, moist air from your Indian Ocean inland. Now, in terms of line thunderstorms, a line thunderstorm is going to be a long, narrow band of thunderstorms that forms over the interior when your cold and your dry air from the Atlantic Ocean meets your warm and moist air from the Indian Ocean. And remember, because your warm air is going to be lighter than your cold air, it's now going to be forced to rise rapidly, right? And as it's going to rise, it's going to cool down and it's going to condense, which is then going to form, your thunderstorms arranged in a line. And instead of occurring as a single thunderstorm cell, many thunderstorm cells develop next to one another, forming a line. Remember, this is not going to be your ordinary thunderstorm, right? It's not going to develop only in one location. A line thunderstorm is basically going to have many cumulonimbus clouds developing side by side. So this is going to be a thunderstorm that literally stretches out over hundreds of kilometers across the country. So some characteristics of line thunderstorms would be that they occur in a long, narrow line. So these thunderstorm cells, they are going to be arranged in a line rather than being isolated. Because remember, these storms are going to develop along your moisture front, right? Obviously where your two air masses meet. They're going to be common in summer because, again, during summer your temperatures are going to be much higher. So there is going to be a lot more moisture available from your warm Indian Ocean. It's going to be associated with your cumulonimbus clouds. And again, these clouds are going to be responsible for your very severe weather. They are going to produce heavy rainfall, and this intense rainfall often occurs over a short period. So remember, you are going to have your large amounts of rain that will fall in a very short time, right? And often your drainage systems cannot keep up with this large amount of rain, and this can lead to your flash flooding. Your line thunderstorms are going to be accompanied by thunder and lightning. They can produce hail, and they can bring about your gusty winds. And lastly, your line thunderstorms, they are going to move across large areas. So they're going to move in a northeasterly direction, and they can affect many towns and farming regions at the same time. So the formation of line thunderstorms looks something like this. So step one, you're going to have your moist air that's going to move inland. So you're going to have your warm, moist air from your Indian Ocean moving inland. So keep in mind this warm moist air, it is going to carry a large amount of water vapor, right? Remember, water vapor is essential for the formation of clouds and rainfall. Step 2, you're going to have your strong surface heating. So your dry continental air, it is going to exist over the interior plateau, right? Your land surface begins to heat up during the day, and the air near the ground becomes very warm and unstable. With step 3, your moisture front develops. So your moist air mass and your dry air mass, they are now going to meet, right? So your moist air meets dry air over the interior. You're then going to have your rapid uplift. So your warm moist air is now going to be forced to rise rapidly while your cold dry air is going to sink. Step 5, condensation occurs. So you can have cooling and you can have condensation that will occur. So your rising air cools and your water vapor condenses. Because remember, we are going to have your warm moist air that is going to be rising into the atmosphere, right? So as it rises, it's going to expand and it's going to cool down. And all the water vapor that's going to be found in this warm air mass is going to change into your tiny water droplets. And that's going to happen when it reaches your dew point temperature, right? And this is exactly what's going to be known as condensation. Remember, condensation leads to cloud formation. Step 6, your cumulonimbus clouds form. So towering cumulonimbus clouds develop and they are going to produce heavy rainfall. Lastly, your thunderstorms are going to join together. So you're going to have several thunderstorm cells that are going to form next to each other. So this is why you're going to have a continuous line of thunderstorms developing. Now keep in mind, line thunderstorms are going to have negative impacts and they're going to have positive impacts. So in terms of the negative impacts that line thunderstorms will have on farmers, firstly, you are going to have crop damage. So you're going to have heavy rain that may flatten crops. Remember, when these crops are going to be flattened by a heavy rain, it's not going to continue to grow properly, right? That's going to make harvesting these crops very difficult. You're going to have hail that can destroy crops within minutes. Remember, you're going to have your large hailstones, right? And as we know, hailstones can be very destructive, right? So they are going to tear the leaves of your plants, they're going to damage any fruit that you are growing, and they can completely destroy your entire field of crops. You're then going to have soil erosion. So intense rainfall is going to wash away your fertile topsoil. Keep in mind, your topsoil is going to contain a lot of nutrients, right? Obviously nutrients that your plants will need for growth. You will have flooding, so your fields may become waterlogged. Remember, when we say waterlogged, basically we're talking about your soil that's going to contain too much of water, right? And it's not going to contain enough oxygen. Crops can drown due to excess water. So keep in mind, when your crops are going to be submerged underwater for a long time, your roots will begin to rot and your plant will die. You're then going to have your livestock losses, so animals can be injured or killed by lightning. Floodwaters may wash livestock away, and you are definitely going to have your loss of income. You're then going to have damage to infrastructure, so your fences, sheds, irrigation systems, and your farm buildings may be damaged. And all of this is going to be very costly to repair. You're going to have delays in your farming activities, so planting and harvesting may be disrupted. And lastly, you're going to have your gale force winds, which will destroy crops. In terms of your positive impacts, your line thunderstorms will provide rainfall, so it's going to supply much needed water for crops. Remember, when we're talking about this rainfall, we're talking about your moderate rainfall, right? Because this rainfall is going to help your crops to grow. We're not talking about your heavy, destructive rainfall. Secondly, it is going to refill your water sources, so dams, rivers, and farm reservoirs, they will receive water. So it improves soil moisture, which is going to be beneficial for crop growth if rainfall is not excessive. In terms of strategies to reduce the impact of severe thunderstorms, firstly, you will need to use weather forecasts. So you will need to monitor weather warnings, because remember, this is going to give farmers some time to, prepare for your storm that is going to be approaching. So your equipment can be secured, your livestock can be moved to safer areas. You will then need to plant windbreaks, because trees can reduce your wind damage to crops. Remember, if you can have your rows of trees, they're going to act as, barriers, and they will slow down your strong winds. So your crops will be protected from any damage. Thirdly, you will need to improve your drainage systems, so construct drainage channels to remove excess water. So by doing this, obviously your farmer will be able to reduce your flood damage to his crops. You will need to protect your livestock, so move animals to sheltered areas during storms. Install lightning protection, so use lightning conductors on your farm buildings. Keep in mind, these lightning conductors that you're talking about, that's going to now, channel all your electrical energy into the ground, and this is going to reduce your damage to buildings or equipment. You will also need to implement your hail protection measures, so use hail nets where economically feasible, because again, if you are going to use your hail nets, that is going to be a physical barrier between your crops and your hailstones. You will need to keep feed and water supplies for emergency. Farmers can diversify farming activities so they can grow different crops. So growing different crops will reduce overall risk. Because keep in mind, if one crop is going to be damaged by a thunderstorm, obviously your farmers, they can still earn money from your other crops. And lastly, farmers will need to have an emergency evacuation plan. So there needs to be a plan for your workers, for your livestock, and for equipment as well, as it will ensure that everything can be moved to safety when your thunderstorm will approach. So now let's go over the low pressure systems over South Africa. So what is a coastal low? A coastal low is a small, weak, low pressure system that develops along the South African coastline. Now, unlike your mid-latitude cyclone, which is going to be a large weather system, a coastal low is going to be much smaller and it is going to be weaker. And since it is going to be forming, close to the coast, it is going to be influencing the weather conditions of these coastal areas. Now, in terms of the characteristics of your coastal low, firstly, it is going to be a small, weak cell with a diameter of 100 kilometers. So keep in mind, a mid-latitude cyclone, it can literally stretch over hundreds of kilometers, right? So this is going to make your coastal low much, much smaller, and obviously because of its small size, it's only going to be able to affect your coastal regions. It forms along the west coast of South Africa, and because it moves southwards, it moves towards the east coast. It's going to develop due to the temperature differences between the land and the ocean. Because remember, your land is going to heat up and it's going to cool down much faster than your ocean. And because of the differences in temperature, you're also going to have your differences in pressure, right? And this is what's going to help your coastal low to develop. Your coastal low is going to have a shallow vertical extent, which means that it's not going to extend high into the atmosphere. So unlike tropical cyclones or mid-latitude cyclones, your coastal low, it's not going to extend very high into the atmosphere. Air converges towards the center of your low pressure system. Now keep in mind, this inward movement of air is going to be known as convergence, because remember, you're going to have low pressure at the center, so all of your surrounding air, it's now going to move inward towards that low pressure center. So just keep that in mind. Your winds are going to circulate clockwise around your low pressure center. And that's obviously going to be because we are in the southern hemisphere. So in terms of the weather associated with coastal lows, firstly, you are going to have strong winds along the coast. It is going to produce fog along the west coast, because remember, your cold Benguela current, it is going to cool the moist air above it. And that's then going to cause condensation, which is going to lead to the formation of fog. You are going to have warm temperatures ahead of your coastal low. Cloudy conditions may occur. It can cause light rainfall and unstable weather conditions along the east coast. And that's simply because your east coast, it is going to be influenced by, your warm, moist air from the Indian Ocean. So all of this moisture, it is going to produce cloud cover, it's going to produce drizzle. And lastly, when your coastal low and your Kalahari high interact with one another, it is going to result in Berg winds. Remember, your berg winds are going to be your hot and dry winds. Next, we are going to be looking at your thermal low, which is also going to be known as your heat low. So a thermal low, also known as a heat low, is a low pressure system that develops over land due to your intense heating of the Earth's surface. So during summer, the interior of South Africa, it is going to receive very strong solar radiation. So this means that your land, it is going to heat up much faster than your surrounding oceans. And obviously this is going to cause the air above the land to become very hot. Now as this air is going to heat up, it's going to become less dense, right? So it's going to expand and it's going to rise into the atmosphere. And as this air is going to rise, your pressure at the surface, it's now going to decrease. And that's what's going to create your thermal low. So in terms of characteristics of your thermal low, it is going to form over the interior plateau during summer. And that's because the interior plateau, it's going to experience very high summer temperatures. Your thermal low is going to be caused by intense heating of your land surface. So air that's going to be in contact with the Earth's surface is going to heat and is going to converge towards a low pressure center. Hot air is going to expand and it's going to rise. Because remember, warm air is going to be much lighter and it's going to be much less dense than your cold air. So that's what's naturally going to cause this air to rise through the atmosphere. Your rising air is going to create a low pressure center at the surface. And there are usually going to be more than one thermal low over the interior of the country. Because remember, the interior of our country, it's going to be such a large area that different locations, they are going to heat up at different rates, right? That means that you can have several different thermal lows developing simultaneously. It's going to be strongest during your hot summer afternoons, and it is going to weaken or disappear during winter when your temperatures decrease. Because remember, during winter, your land surface is going to be much cooler. So in terms of the weather associated with your thermal low, you are going to have very hot conditions, right? You're going to have rising air, which is going to encourage cloud formation, and this can lead to convectional rainfall and thunderstorms over the interior. So if there is going to be enough moisture available, all of this rising air, it's now going to form your large cumulonimbus clouds. And as we know, cumulonimbus clouds, they will produce heavy rainfall, thunder, and lightning. And thirdly, we are going to have your cut-off low. So basically, when your South Atlantic high and your South Indian high, it's going to extend along the south of the country, they are going to act as a barrier. So basically, they're going to be stopping a mid-latitude cyclone from continuing its normal eastward movement. So basically, this is going to create like a blocking effect. And as a result of this, part of your cyclone is now going to be trapped over South Africa. A cutoff low develops when the cold front of a mid-latitude cyclone becomes separated from the main cyclone, leaving an isolated low-pressure system over the land. So basically, as your blocking effect is going to develop, a cold front is now going to become separated from your main cyclone. And this detached section, it's now going to move over land and it will then, develop into a cutoff low. And this is only a temporary weather condition. Because remember, cutoff lows, they're not going to last forever. Eventually it's going to weaken or it can dissipate completely. It's going to occur in the upper atmosphere and it can remain stationary for several days. And this is going to be one of the main reasons why a cutoff low, it can cause prolonged rainfall. It's going to be common during autumn and spring, but it can occur at any time of the year. And it will draw moist air from your Indian Ocean, which will obviously cause, your large amounts of cloud cover and rainfall. So in terms of the weather associated with cutoff lows, you're going to have heavy and prolonged rainfall, and many times this will lead to flooding. You will have thunderstorms, flooding, hail, and in some cases you will have snow on your high-lying mountains during winter. Because during winter, your cutoff low, it can lower temperatures enough for snow to fall, obviously on your mountain ranges.
So today we are taking a look at berg winds. We will be looking at what they are, how they form, what causes them, what the effects are, and also what impacts they have on our country. So what are Berg winds? Berg winds are hot, dry winds that occur in the interior of South Africa. Now remember those two key words, right? Hot and dry, because essentially that's what a Berg wind is. It's a hot and dry wind. These winds will blow from the interior of the country towards the coast during winter months, and they typically occur from April to September. So how do these Berg winds actually form? Now we'll first go through a quick summary just to gain a basic understanding, and then we'll dive into this topic in detail. So Berg winds will form as a result of the following combination of factors. Number 1, high pressure systems in the interior of the country cause the air to sink. This high pressure system is known as either the continental high or the Kalahari high. Now continental high and Kalahari high is the same thing, it's just different names, right? So as the air descends from the high altitude areas, it warms up due to compression, and this is a process known as adiabatic heating. Now fear not, I will explain exactly what adiabatic heating is. Our third point states that this dry, warm air then moves towards the lower lying coastal areas where it is felt as a warm wind. Now as you can see from this summary, in its most basic form, there's only 3 major steps in the formation of Berg winds, right? First obviously is the Kalahari high, it's going to cause the air to sink. Then as we have the air descending, adiabatic heating is going to take place. Now as I mentioned in that point, adiabatic heating is the warming up of air as it compresses. After that obviously the warm air will then move towards the coastal areas where it will be felt as a Berg wind. So let's go into further detail about how do Berg winds form. So the first reason for formation is due to the high pressure systems over the interior. Now obviously we know what high pressure systems are. They are areas where the air pressure is much higher than the surrounding areas. So in the interior of South Africa, a subtropical high pressure system forms. This system will be known as a continental or Kalahari high. This is a large area of sinking air that causes the atmosphere to compress and warm up. The high pressure system creates a stable environment which prevents the warm air from rising, keeping it trapped near the ground. Now the most important point that you need to know from this information is that the formation of your Berg winds is going to be caused by a high pressure system over South Africa's interior. Now this high pressure system is going to trap air and it will prevent it from rising, which will create a stable environment. So now we'll be talking about how your air sinks and warms up. So as the high pressure system dominates, air begins to sink or descend from the upper atmosphere towards the surface. Now this is called subsidence. Now as the air sinks, it is compressed, and compression causes the air to heat up. Now this is known as adiabatic heating, right? It is the compression of air, and that compression is going to cause the air to warm up. Essentially, as the air molecules are forced closer together, they start moving faster, which increases the temperature. And another thing to note is that the Berg winds can reach temperatures of 30 degrees Celsius or more. So just to summarize this piece of information, as the high pressure system dominates, air sinks towards the surface, it compresses, and it heats up due to adiabatic heating. Now this is what's going to cause the temperature of the wind or the air to rise. So for those of you that are still confused by adiabatic heating, here's a simple explanation of what it is. So before compression, while your air is high up in the sky, your air molecules are spread out and moving slowly, so the air is cool. Now as you can see in the jar on the left, those circles are going to represent your air molecules. And can you see how they're going to be spread apart, right? They are far from each other and they are moving very slowly. Now as the air sinks, it's going to move into areas with higher pressure, which squeezes the air molecules closer together. Now after compression takes place, right, when your air is closer towards the ground, the molecules are now packed tightly, they bump into each other more often, and they move faster, making the air hotter. Now as you can see in the jar, the air molecules are going to be located much closer to each other, and they're going to start bumping against each other, right? And that's going to generate heat. As you can see, the color is different from the jar on the left. So now that the molecules are bumping into each other much more often, these frequent and energetic collisions are going to increase the temperature of the air, because we know temperature is a measure of the average kinetic energy of molecules. So those of you that are actually doing physics, you're going to understand this concept a lot easier. So now we will talk about the movement of the air towards the coast. So once the air has been warmed up, it moves towards the coast in an anti-clockwise direction. Since it is a high pressure system, the winds move from areas of high pressure to areas of lower pressure, like the coastal regions, towards the coastal low. As the air moves, it stays warm and dry because it has already lost much of its moisture while descending and warming in the interior. Now, a very important point to remember is that for every 100 meters we move, the wind will warm up by 1 degree Celsius. So now we get to the end result, which is a warm, dry wind. The result is a warm, dry wind that blows from the interior of the country towards the coast, and they can last for several days. Our next point states that the warm air is very dry because most of the moisture has already been lost as the air moves across the land. This contributes to the low humidity that characterizes Berg winds. Now, as your air moves from a high pressure area to a low pressure area, it's going to pick up speed, making the wind quite strong. Now let's quickly take a look at this diagram. So this diagram will give us a visual representation of what the entire process will look like. Now at A, you can see that the air will subside at the Kalahari High, which is obviously located over the interior of South Africa. Now once we get to B, we can see that the air is going to compress and it's going to then move towards the coast. Now at C, the air is then going to move down the escarpment, and you can see how the colors of the arrows are going to change from dark blue to red. Now this is going to indicate the change in temperature of the wind, right, from a cool wind to a warm wind. Now remember, I mentioned that for every 100 meters the wind will move, the temperature will increase by 1 degree Celsius. Now we look at D. The wind has now reached the coastal low at the coast, and it can reach temperatures of 30 degrees Celsius or more. So now let's look at some characteristics of this wind. The first will be that it is warm and dry. As the air is compressed, it heats up, making the winds hot and dry. The next characteristic would be that it is a strong wind. So Berg winds can reach speeds of 50 to 70 kilometers an hour, although they are not as strong as other winds. Another characteristic would be the direction. So they usually blow from the interior of the country to the coastal areas. And the last characteristic would be the duration of the wind. So Berg winds often last for several days. So what are some environmental effects of Berg winds? The first would be drought and fire risk. So the hot, dry conditions created by Berg winds can lead to increased evaporation rates and exacerbate drought conditions. The low humidity also increases the risk of wildfires, especially in areas with dry vegetation. Now we know, because Berg winds often occur in winter, remember, vegetation is going to be dry because basically the wind is hot. These areas with dry vegetation can catch alight, causing wildfires. Next would be temperature changes. So areas affected by Berg winds experience a noticeable increase in temperature, often by several degrees Celsius, which can be uncomfortable and lead to heat-related stress on plants, animals, and humans. The next environmental effect would be drying out of soil. So with a strong evaporation rate, soils can become drier, affecting agriculture and water supplies. So now, not only did we look at the effects of Berg winds, we will now look at the impact of Berg winds on people and the economy. So the first will obviously be health issues. So the hot, dry winds can cause discomfort to people, leading to dehydration, heat stress, and respiratory issues, particularly in people with pre-existing lung conditions. The next would be agriculture. So farmers will face crop damage due to the hot temperatures and drought conditions that are intensified by Berg winds. The winds may also damage crops that are sensitive to excessive heat. As we mentioned, also there's an increased fire risk. The winds will contribute to a higher frequency and severity of wildfires, which can damage properties and agricultural land. This affects communities and industries, especially those involved in farming and tourism. And the last will be obviously the economic costs of the winds. The environmental damage caused by Berg winds, such as crop loss and destruction of property, can result in economic losses. Additionally, firefighting efforts and damage control during these events lead to increased costs for local governments and businesses. So now we can clearly see that these winds are going to have a negative effect not only on the people, but the environment and the economy.
So let's quickly go over local climate, valley climate, and slope and aspect. So what is local climate? Local climate, also known as microclimate, refers to the study of climate conditions over a small specific area. Now remember, this is going to be the climate of a very small area, right? And it can be different from the surrounding region. Now keep in mind, even though two places can be close together, you're going to have different factors such as slope, such as vegetation, even human activities that can cause differences in the temperature and the rainfall of these two places that are close together. So what are some characteristics of your local climate? Firstly, it is going to be influenced by local factors. That means that your local climate, it can be influenced by factors that are going to be found in that specific area. So things like buildings, things like vegetation. Local climate is going to cover a small area. Remember, when we're talking about local climate, we can even be talking about a single valley, right? We can be talking about a farm, maybe even a forest. Local climate can vary over short distances. So things like temperature and weather conditions, they can change very drastically over a short distance. For an example, think of a valley. So one side of the valley can be warmer than the other side, even though it's only going to be like a few hundred meters apart. And your local climate is going to be affected by relief, vegetation, water bodies, buildings, and human activities. Now, some examples of local climate include a valley being colder than your nearby hills, a city being warmer than your surrounding rural areas. Remember, this is going to be known as your urban heat island effect. And if you remember what this is, you know that your buildings, your roads, all of that is going to absorb heat and it's going to release it. And this is what's going to cause your urban areas obviously to be warmer than your surrounding rural areas. And your last example would be a forest being cooler than an open grassland. Remember, if you can have a lot of trees, trees are going to provide shade, right? Now, local climate is going to be very important for agriculture because remember, some crops, they're going to prefer cooler conditions and others are going to require warmer conditions. That's why farmers will need to know which crops to plant in which area. Local climate is also important for your settlement patterns because remember, people want to live in areas that are going to have your favorable climate conditions. They don't want to live in areas that are going to be either too hot or too cold. And just like agriculture, it's also going to be important for vegetation because remember, different plants are going to grow best under different climate conditions. And lastly, you're going to have your human activities. So what is a valley climate? A valley climate is the climate found within a valley and is mainly influenced by the movement of air up and down the valley slopes. Now, in a valley during the day, your slopes are going to heat up quickly because remember, they're going to be directly exposed to your sunlight. You're going to have warm air that's going to rise up the slopes, and that's going to happen when the air that's going to be in contact with these slopes, it's going to heat up, it's going to become less dense, and it's going to begin to rise. And remember, this is going to be known as an Anabatic wind. In terms of your nighttime conditions, during the night, your slopes are going to cool down rapidly. Keep in mind, after sunset, your ground is going to lose all of its heat, and that's going to be through terrestrial radiation. You're going to have cold, dense air that's going to flow downslope, and that's going to happen when the air that's going to be near your slopes is going to cool down, right? And when it's going to cool down, it's going to become dense and it's going to become heavier. And because of that, obviously gravity is now going to cause this cold air to flow down the slopes towards your valley floor. And this is what's going to be known as a Katabatic wind. Now, if you know the effects of your Katabatic wind, you would know that your cold air is now going to collect at the bottom of the valley. That means that your valley floor is going to become colder and you're going to have frost that will form on the valley floor. Now, what is slope or aspect? Aspect refers to the direction that a slope faces in relation to the sun's rays. Basically, aspect is going to tell us in which direction a slope is facing. Remember, different slopes are going to face the sun differently, and that means that they will receive different amounts of sunlight. And this is obviously going to affect the temperature, the vegetation, and it's also going to affect where people choose to live. Now, in South Africa, because it's found in the southern hemisphere, the amount of sunlight received depends on the slope's direction. Now, because we are in the southern hemisphere, keep in mind the sun is going to be positioned towards the north. That means that your north-facing slopes, those are going to receive more sunlight than your south-facing slopes. Slopes facing the equator are going to receive direct insolation and are warmer. Now, if you're going to have an equator-facing slope, it's basically going to be a north-facing slope. That means that it's going to receive direct sunlight, and it's going to be warmer. Slopes facing the poles receive oblique insolation and are cooler. Some characteristics of north-facing slopes would be warmer temperatures. You're going to have higher evaporation rates, because remember, if you're going to have more heat, you're going to have more water evaporating from your soil and from your vegetation. You're going to have drier conditions, so as your moisture is going to be lost through evaporation, you're going to have your drier conditions. And as a result of your drier conditions, you are going to have less vegetation. Now, if you were to compare this to your south-facing slopes, your south-facing slopes are going to receive less direct sunlight. And that's because they're going to be facing away from your equator. And all of this basically means that you are going to have cooler temperatures, you're going to have lower evaporation rates, because remember, with lower temperatures, there's going to be less water that's going to be lost from your soil and your plants. You're going to have more moisture, which means you are going to have more vegetation. Now, aspect is going to influence both human activities and it's going to influence the environment. Now, in terms of the influence of aspect on economic activities, you're going to first have agriculture. So on your north-facing slopes, you can have warmer temperatures, which means you can have a longer growing season. You're also going to have crops maturing faster. So keep in mind, high temperatures are going to help your crops to ripen quicker. And your north-facing slopes are going to be suitable for crops that require more heat and sunshine. An example would be grapes for winemaking, because they require sunlight to ripen and sweeten. In terms of your south-facing slopes, you're going to have cooler temperatures, which means you're going to have more moisture available, and your south-facing slopes are going to be suitable for crops that require cooler and wetter conditions. So an example would be citrus, because you're going to have thick skin. In terms of livestock farming, your south-facing slopes are often going to have more grass, and that's going to be due to your higher moisture levels. And that's also going to provide better grazing for livestock. Remember, if you're going to have more grass, that means you're going to have more food available for your cattle, for your sheep. And in terms of forestry, your trees are going to generally grow better on cooler, moister, south-facing slopes. Because remember, your trees are going to require large amounts of water. And your south-facing slopes, they are going to have better moisture retention. So obviously that's going to mean that your trees are going to have enough moisture for their growth. And just like we mentioned, greater water availability supports forest growth. Now, in terms of your influence of aspect on settlements, your north-facing slopes are going to be preferred for settlement in South Africa. Remember, people generally prefer to live in areas that are going to be warmer. And that's basically because it is going to be more comfortable to live there. Your north-facing slopes are going to receive more sunlight during winter. You're going to have warmer living conditions, you're going to have lower heating costs, and remember, that is going to reduce your electricity expenses. Property values will be high, and it will become a high-income residential area. Remember, these warmer locations, they are going to be desirable, which means that there is going to be a demand, and if there is going to be a demand, your property prices will increase. In terms of your south-facing slopes, it is going to be cooler, it's going to receive less sunlight, it can be damp and colder during winter, and it's going to be less attractive for residential development. Because again, people want to live in warmer areas. In terms of the influence of aspect on vegetation, Your north-facing slopes are going to have higher temperatures, which means you can have greater evaporation. So you are going to have drier soils. Remember, drier soils are going to limit plant growth, so your vegetation tends to be less dense. Drought-resistant plants are common, so an example would be grass and succulents. However, in terms of your south-facing slopes, you're going to have cooler temperatures, you're going to have lower evaporation rates, you're going to have more soil moisture, which means you're going to have denser and greener vegetation. So you're going to have forests, you're going to have shrubs, and you're going to have ferns.
Today we are looking at valley winds. We are looking at things like how they are formed, the characteristics, as well as the effects. Basically everything you need to know for the exams. I will also be including diagrams that very often appear in exam papers. So let's start off with katabatic winds, right? Katabatic winds are winds that flow downhill from higher elevations such as mountains or hills to lower areas like valleys. The word katabatic comes from the Greek word katabatikos, meaning to go down. Now this definition can be used in your exams, so please feel free to take a screenshot and keep it for whenever you are actually studying. So how do katabatic winds form, right? What are the factors that cause them to form? The first would be nighttime cooling. So at night, the land surface cools down quickly after the sun sets, and in hilly or mountainous areas, the air near the slopes cools down faster because cold air is denser and heavier than warm air. So let me break this down and give you just the main points. So basically at night, your land surface will cool, right? And the air that is directly above that will also become cold and heavy. So this cold air will then move down the slope and into the valley, and this will create a downhill wind, right? So that's our very first point. Our second point states cold air sinks. Now as the air cools, it becomes heavier and starts to flow downhill along the slopes. This movement of cold, dense air is what we call a katabatic wind. Remember, gravity is going to pull this heavy wind down the slopes, right? And that is basically how we get the downslope movement. Our third point states settling in valleys. So the air flows down into the valley, replacing the warmer air and causing the temperature in the valley to drop significantly, especially during clear and calm nights. So this point is basically emphasizing the fact that once the cold air reaches the bottom of the valley, it will then push any warm air that is within the valley upwards, right? And this is going to make the valley very cold. Now let's look at some characteristics of katabatic winds. The first characteristic would be the temperature of the wind itself. Remember, it's going to be a cold wind. So since katabatic winds are cold air flowing downhill, they generally bring cooler temperatures to the areas that they reach. Now this can be asked to you in an exam in multiple ways. That's why it's best for you to truly understand it rather than just memorizing it. The second characteristic will refer to the strength of the wind. So it can either be gentle or strong. Katabatic winds can range from light breezes to stronger gusts, depending on how steep the slope is and how much the air has cooled. So there are two important factors that we can identify in this point, right? The first will be the gradient of the slope. And obviously gradient is basically how steep a slope is. And the second will be how much air has cooled, right? That will determine the strength of the wind. The third characteristic would be that it is common during the night time. These winds usually happen at night or during the early morning when the ground cools down the fastest. Now this point is pretty self-explanatory, right? So before we get to the influence of katabatic winds on farming, are we all good? Are you guys confused about anything? If you do have any questions, then please leave it in the comment section and I will get back to you as soon as I can. So let's look at the influence of katabatic winds on farming, as this can be asked as an essay question in your exam. So the first influence would be frost risk. Katabatic winds bring cold air down into valleys, which can lead to a significant drop in temperature, especially at night. This can cause frost formation, which poses a serious threat to crops, particularly those sensitive to freezing conditions like fruits and vegetables. Now, frost is actually a layer of ice crystals, and frost will form when your water vapor in the air will turn directly into solid ice. Right? And this will generally happen on surfaces that are below freezing temperatures. And when you're going to get a significant drop in temperature, frost is going to form on the floor of the valley. Farmers may choose to grow oranges on the floor of the valley, and the cold conditions assist in destroying insects which damage crops. Now farmers also choose oranges because oranges have a thick skin, so the frost is not very likely to affect these oranges, right? Cold weather crops. In areas with persistent katabatic winds, farmers may opt to grow hardier, cold-resistant crops like root vegetables, example carrots and potatoes, that are less susceptible to frost damage. Now we are looking at the influence of katabatic winds on settlements. Remember, the previous slide was talking about the influence of katabatic winds on farming. So the first influence would be frost pockets. So katabatic winds can create frost pockets in valleys, making these areas less attractive for settlement. Historically, people have tended to settle on higher ground away from cold air in the valley floor to avoid harsh night temperatures. So humans generally prefer to live in warmer areas, right? And some of you may know that if it's a nice cold night and you snuggled in and you just found a comfortable spot under the blanket, you then get the feeling that you need to go to the bathroom. And now you need to get out of that comfortable spot and go out in the cold again. Now people don't want that, right? They want to be in warm areas. So this will definitely influence where they want to live. The next influence will be temperature extremes. So settlements located in valleys may experience significant nighttime cooling due to katabatic winds, which can affect how homes are built and insulated. Houses may need better insulation to protect residents from the cold air that settles in the valley at night. So if you're living in a valley that is very cold, obviously your home will need to be insulated, so you're going to need things like your underfloor heating and things like that in order to stay warm. Now we are looking at the influence of katabatic winds on transport. We are no longer looking at settlements. So the first would be road conditions, right? Katabatic winds can lead to the formation of ice on roads in valleys, making transportation dangerous, especially during early morning commutes. The colder air in valleys can cause moisture on roads to freeze, creating hazardous driving conditions. Now this can be disastrous as it can cause horrible accidents. So this is definitely a negative aspect of katabatic winds. Our next influence will be visibility issues. In some areas, katabatic winds can cause fog or mist to form in the cooler valley air, reducing visibility for drivers and making road travel even more challenging, particularly at night or in the early morning. Now again, this will lead to treacherous conditions on the road. So as you can see, this is the diagram that I was talking about. Now I have taken the liberty of making it nice and colorful, as that will make it easier for you to understand. Now if you do see this in the exam, it is going to be black and white and it's not going to be color coded like this, right? So let's quickly go through it and understand what's taking place. So first we can see the presence of a moon and stars, and that will basically tell you that it's taking place at night. So automatically you should think of a katabatic wind, right? So the white arrows that are facing downwards will represent the downward movement of cool air. And then you can see at the bottom of the valley, there's a blue icon, and that will basically represent frost. Now we can then see two arrows pointing upwards, and that will represent the upward movement of warm air in the valley that is going to be pushed upwards by the cold air. We can then see midway up into the valley, there's a presence of a thermal belt. Now the thermal belt in a valley is basically a warmer zone that is found halfway up into your valley, right? That will be the warmest part of that valley. Now if you do find that this diagram comes out in your exam, you may find out that it's not labeled. You're going to have to either label it yourself, or they're going to ask you various questions based on that diagram. So that's basically most of what you need to know in terms of the diagram and katabatic winds. We will now look at anabatic winds, right? So anabatic winds are the exact opposite of katabatic winds. Remember, katabatic winds are cold winds that will move downhill at night. Anabatic winds are winds that occur during the day, and it is the movement of warm air up a slope, right? So let's look at the given definition, right? Anabatic winds are upward moving winds that flow up the slopes of hills or mountains during the day. The word anabatic comes from the Greek word anabatikos, meaning to rise. As you can see, it is the exact opposite of katabatic winds, so if you can remember one, just think of the opposite and there you have it. So how do anabatic winds form? The first reason is because of daytime heating. So during the day, The sun heats the slopes of hills and mountains more quickly than the surrounding air. The ground warms up and the air directly above it becomes warmer as well. Now this again is the exact same thing that happens with your Katabatic winds. Your slopes will heat up and the air directly above that will also become warm. The second reason as to how Anabatic winds form is because warm air rises. Remember, since warm air is less dense, it rises. As the air heats up along the slope, it starts to flow upward, following the incline of the mountain or hill. Now a very important thing to remember is that warm air rises and cold air sinks, right? That is very important to remember. The third reason is because of wind formation. This upward movement of warm air creates an anabatic wind that moves from the lower valley areas up to the higher slopes. Now this point again is pretty self-explanatory. We will now go over the characteristics of anabatic winds. And the first characteristic is that it is a warm wind. Because these winds are caused by the sun heating the ground, anabatic winds tend to be warmer than the surrounding air. The next characteristic of anabatic winds will be that it occurs during the day, right? It is a daytime phenomenon. So anabatic winds occur during the day when the sun is shining, usually strongest in the afternoon when the surface heating is at its peak. So now we will look at the effects of anabatic winds on the climate. And the first effect would be an increased temperature, right? Anabatic winds can cause the upper slopes to warm up more quickly than the valley floor, influencing temperature variations within a short distance. The next effect would be cloud formation, right? If there's enough moisture in the air, anabatic winds can carry that moisture upward, sometimes resulting in the formation of clouds along the mountain ridges. This is why you often see clouds forming near mountaintops in the afternoon. Now let's take a look at this diagram, right? As you can see, it is a lot simpler than the diagram that we did of Katabatic winds. We can now see the presence of a sun, which is basically indicating to you that this wind is taking place during the day. And we can see there are two arrows that are flowing up the slopes, and these two arrows will basically represent the flow of warm air up the slopes. As you can see, it's pretty simple. There's not too much to learn there. Today we will be talking about rural and urban climates. So we're going to be covering the different weather conditions between rural and urban areas. So we're going to be looking at things like your temperature, wind speed, relative humidity, precipitation, as well as cloud cover. We will also be looking at the factors that contribute to higher city temperatures, as I noticed that can appear in your exam paper. So let's get started. Now we will first start off with this table, and this table will basically go through the different weather conditions that are found in urban areas as well as rural areas. So the first condition would be temperature. Now obviously in urban areas you're going to have a higher temperature, whereas in a rural area you're going to have a lower temperature. Now what is the reason for that? Now as I said in the intro, I will be going through this in detail once we're done with this table. Now let's look at wind speed, right? Wind speed is our second factor. So in urban areas, it's going to have a lower wind speed, whereas in rural areas, there's going to be higher wind speeds. Now what is the reason for that? That is because tall buildings in urban areas create wind barriers and reduce airflow, while rural areas have fewer obstacles, allowing wind to move more freely. Now think about this for a second, right? Think about a city with tall skyscrapers that are all built close to each other. Those buildings are going to block the airflow, and obviously that's going to slow down the wind speed. Therefore, urban areas are going to have lower wind speeds. So our next factor would be humidity. Now in urban areas, there's going to be lower humidity due to high temperatures and reduced vegetation. Remember, urban areas are not going to have a lot of vegetation, whereas in rural areas, there's going to be higher humidity because of more vegetation and open spaces. Now what is the reasoning for this, right? What is the final reason? This is because cities tend to have lower humidity due to heat and lack of vegetation, while rural areas benefit from more vegetation that increases moisture in the air. Now another thing that's not mentioned here is that we need to know that urban areas will have drainage systems, right? And this drainage system is going to channel water away from the city. And we know that once this water goes away from the city, there's going to be less moisture, and in turn there's going to be less humidity. So that's something that we also need to remember. So now we will look at precipitation, right? Urban areas are going to receive more rainfall due to urban heat, whereas rural areas will receive lesser rainfall than urban areas. Now, cities often experience rainfall that is more intense due to warmer conditions. We will now look at cloud cover. So in urban areas, there's going to be a higher cloud cover, and that is due to more heat and pollution. Whereas in rural areas, you're going to have a lower cloud cover, and in turn, that is going to lead to clearer skies. So what is the reason for this? The heat generated in cities causes rising air currents that contribute to cloud formation. Rural areas with fewer pollutants and lower temperatures typically have clearer skies. Now let's look at the factors that contribute to higher city temperatures. The first would be the actual materials that are used to build these large buildings, right? So our point states concrete and metal absorb heat. So buildings are built using concrete and metals which retain heat. Now in this picture, we can see that this is a modern office in one of these skyscrapers, right? And we can see a lot of concrete and metal elements. Now these two materials are known for absorbing and retaining that heat. And that's going to lead to very warm conditions. The next point states that modern day buildings are constructed using glass and mirrors which lead to the reflection of heat, which in turn raises temperatures. Now in this office picture, you can see there are large windows. And remember something about these windows, right? If you look at this photo right here, we can see on the outer end of those large windows, you can have a mirror finish. And because these windows, these large windows, have a mirror finish on the outer end, the sun's rays that are going to strike that material are then going to be reflected off of that building and onto the next building. And because the next building will also have a mirror finish, it's then going to constantly be reflected between buildings, and that's going to increase the heat between those two buildings. So this point is stressing the fact that large windows and mirrors are going to constantly reflect the sun's rays, and that's going to increase the temperature in this area. So tall buildings trap heat. Skyscrapers and narrow streets reduce air circulation, preventing heat from escaping. Now remember, because these buildings are built so close to each other, it's going to cut off any airflow between the buildings, and that's going to lead to the hot air building up between these buildings, and that's going to lead to much hotter conditions in that area. Our next point looks at the lack of vegetation. So because there are fewer trees and green spaces, it means that there is less shade and cooling from transpiration. In contrast, rural areas have more plants that cool the environment. Now when you think of a city, you don't really think of trees and a lot of greenery. And that's what this point is trying to explain. Next would be high energy consumption. So cars, air conditioners and factories generate heat, increasing city temperatures. Now this point talks about air conditioners. Now air conditioners are not the only machines that generate heat. Remember, other machines such as heaters, geysers, as well as your cooking apparatuses, so things like stoves, they all will generate heat. Our next factor talks about dark surfaces. So roads and rooftops are made of dark materials like asphalt, which absorb more heat instead of reflecting it. Now I don't know if anyone has ever told you on a hot day to not wear black clothes because it will absorb heat. Now this is the same principle as what this point is trying to state. Carbon emissions from vehicles and industries trap heat in the atmosphere, contributing to the warming of urban areas. Now as you can see, in a city there's going to be tons of vehicles that are going to be used, and all of these carbon emissions from the vehicles are going to trap heat in the atmosphere, and that will lead to the warming of urban areas. Our last point talks about human activity. So the constant movement of people, vehicles and machinery generates additional heat. And that's pretty self-explanatory, right? So today we're going to be taking a look at urban heat islands as well as pollution domes, right? We're going to be going through the following aspects in relation to both heat islands and pollution domes. Now UHI will stand for urban heat islands, so if you do see this in an exam, then you know exactly what they are referring to. So what are urban heat islands? An urban heat island refers to urban areas that are significantly warmer than their rural surroundings due to the human activities and the physical characteristics of the built environment. So basically it's an urban area that's going to be much hotter than the rural surroundings, right? And the urban heat island will occur during the day. Now this is a visual representation of what an urban heat island is going to look like, right? And a graph like this can appear in your exam, so let's quickly go through it. As we can see, right, this graph is going to indicate the different temperatures of different places. Now the y-axis is going to represent the different temperatures, whereas the x-axis is going to represent the different areas. Now remember, the y-axis is a part of the graph that goes up and down, whereas the x-axis is a part of the graph that goes left and right. So on the x-axis, on the left-hand side, we can see that this area is going to represent a rural area, right? And the temperature reading for this rural area is going to be 26 degrees Celsius. Now as we move to the right-hand side, we go from the rural area to a city center. Now at the city center, you can see that the temperature reading is going to skyrocket from 26 degrees Celsius to 33 degrees Celsius. Now this is basically what the urban heat island is. Can you see how much hotter it is in the city as compared to the rural area? Now this is due to the human activity that will take place in cities and will contribute to that heat. So examples of these human activities will be things like the use of private vehicles, public transport, machinery, also the lack of greenery, right? That's also a major factor that will contribute to urban heat islands. Now if we continue moving to the right, we can see that we then get to a suburb or a residential area, and the temperature will drop down from 33 degrees Celsius to about 27 degrees Celsius. Now while this is significantly cooler than the city, it's still going to be warmer than the rural area. Now the reason why the suburb will be much cooler than the city center is because there's going to be a lot less industrial activities taking place, right? There's not going to be so many people packed together, and there's going to be a lot more green spaces that's going to be found in the suburb as compared to a city center. We can then look all the way to the right, and we can see that the temperature goes all the way back down to 26 degrees Celsius in the rural area. Now I hope this diagram is going to make things a lot easier for you to actually understand. Now as I mentioned earlier, this graph can appear in your exam. That's why it's so important that you actually analyze it in detail before you actually look at any questions. So what are the causes of urban heat islands, right? The first will be increased impervious surfaces. So roads, buildings and concrete absorb and retain heat. Now we know cities have a lot of roads, buildings and concrete, and all of these materials are going to absorb and store the heat that we receive from the sun, right? Now if you look at natural surfaces, so things like grass, soil, all of these surfaces, right, the natural surfaces are going to cool down quickly as compared to concrete and asphalt, which are going to release the heat very slowly. Now this is going to make your urban areas even warmer. So next we look at the lack of vegetation. So cities are going to have fewer trees and green spaces, which are natural coolers. So as we know, trees and plants cool the air by providing shade and releasing moisture. Now in cities, because we know there's hardly any trees and green spaces, there's going to be less shade and there's going to be less cooling. So this is going to lead to a rise in the temperature. Now if you can think about walking in a park, right, walking in the shade, think about how much cooler that is going to be than walking in a city center, right? There's going to be a huge difference in the temperature. Our next point, we look at human activity, right? That's another major cause of the urban heat island. So high energy consumption, transportation emissions and industrial activities would release additional heat. So cars, factories and aircons are all going to release heat and pollution, right? We know that very well. And because there's going to be such high energy use in cities, so things like using your lights and machines, that's also going to generate a lot of heat. And that's what's going to make your urban areas even hotter. So now let's look at some characteristics of urban heat islands, right? The first would be higher temperatures. Urban areas are hotter than surrounding rural areas, especially in summer. Obviously, we just spoke about your heat absorbing surfaces, your fewer trees and human activities, and all of those are going to lead to these higher temperatures. Another characteristic would be prolonged heat. Now these areas are going to retain heat longer into the night due to the heat retained by buildings and pavements. Because remember, these buildings are going to absorb heat during the day and they're going to release it slowly at night. And this is going to keep the urban areas warmer for longer, whereas your rural areas are going to cool down much faster. Another characteristic would be air quality issues. So increased temperatures exacerbate air pollution and the formation of ozone. So these higher temperatures are going to trap pollution and it's going to increase the formation of ozone. Now ozone is also known as smog. And this is basically going to make the air that is found in cities much more polluted, which is going to affect health and visibility. So now we come to pollution domes, right? Pollution domes are also known as dust domes. So what is it? A pollution dome or dust dome is a layer of air pollutants trapped over an urban area, forming a dome-shaped structure of smog, dust and other pollutants. Now, two things to note is that it's going to be more concentrated at night and it will take a dome shape. So those are two easy ways to identify a pollution dome. Now this is an idea of what it will look like. As you can see, this is a city at night and you can see there's a dome shape over the city. Now this pollution dome is going to be much more compressed at night due to subsiding air. Remember, the subsiding cold air is going to trap all the pollutants and this will prevent it from rising into the upper atmosphere. Now another very important fact about the pollution dome is that it's going to be associated with acid rain. Now we are going to talk about this later in the video. And the pollution dome can also be dispersed by either strong winds or rain. Now those are a few extra important points. So what will cause the pollution dome, right? The first will be industrial emissions. So factories and power plants release pollutants like sulfur dioxide and nitrogen oxides. Now these chemicals are going to mix with the air and that's basically going to contribute to smog and poor air quality. Our next point is talking about vehicle exhaust. Cars, trucks and buses release particulate matter and carbon dioxide. Now all these tiny pollution particles will then rise up into the air and it's going to build up over the city. And this is going to make the air quality a lot worse and will further contribute to the formation of a pollution dome. Another major cause will be the temperature inversions. So during certain weather conditions, cooler air at ground level traps pollutants below a warmer layer of air above. So basically a layer of cool air is going to get trapped below warm air and that's going to prevent pollutants from rising up and dispersing. Now in some areas, dust is blown into the air, contributing to pollution domes. Now we know in dry and windy areas, obviously dust is going to be blown into the air. And once this dust is going to get trapped in the pollution dome, it's going to make your air quality a lot worse. So what are some characteristics of pollution domes? The first will be air pollution. So poor air quality with high concentrations of smog and particulate matter. Now we know cities are going to have poor air quality due to high levels of smog and your tiny pollution particles. And this is going to make the air very unhealthy to breathe in. The next characteristic will be visibility issues. So the pollution is going to reduce visibility, especially in the morning and evening. So the pollution is basically going to block your sunlight and that's going to reduce your visibility, especially in the morning and the evening when your air is cooler. Now the most important characteristic will be your health hazards. The trapped pollutants contribute to respiratory problems and other health issues. So all of these pollutants are obviously going to irritate your lungs and that's going to cause breathing problems, right? Breathing problems, allergies and other health issues. So very common lung diseases that you can get is lung cancer, COPD. So COPD stands for chronic obstructive pulmonary disease. But a lot of people don't realize that your heart can also be affected by these pollutants. Now another characteristic will be that it is more concentrated at night and it is dome shaped. So what are some effects of the urban heat island? What are the negative points associated with heat islands? Be it on people, be it on the urban area itself. The first is going to be an increased energy consumption. So more electricity is used for air conditioning and cooling, which is then going to put pressure on energy resources. So we know that the urban heat island is going to lead to high temperatures and this is going to cause people to use their air cons a lot more. And because more air cons are being used, that's going to lead to an increase in the energy demand, which is then going to put extra pressure on energy resources and that's going to raise your energy costs. Another effect is going to be your health impacts. So higher temperatures are going to increase the risk of heat stroke, dehydration and other heat related illnesses, especially for vulnerable populations. So the vulnerable populations that they are talking about are basically the elderly, children, and also those with pre-existing conditions. Another environmental impact would be higher temperatures lead to greater demand for water, affecting water resources and ecosystems. So higher temperatures are definitely going to increase the demand for water, so for things like cooling, irrigation, and this is definitely going to put pressure on water resources. Now let's look at the effects of pollution domes, right? Remember, we were looking at the effects of urban heat islands before this. So the first would be health risks. So poor air quality leads to respiratory problems, asthma, and cardiovascular diseases. Children and elderly are particularly at risk. The next effect would be acid rain, right? Acid rain is going to stunt the growth of plants and it's going to corrode buildings. So acid rain is basically rain that has been polluted with sulfur dioxide as well as nitrogen oxides. Now, these chemicals are going to mix with water vapor in the atmosphere to form sulfuric acid and nitric acid. Now, as mentioned in the point, this acid rain is going to damage plants by stunting their growth, and it's also going to corrode buildings and structures that are made with stone or metal. So our next point talks about visibility issues. So smog and haze reduce visibility, which can affect road safety and daily activities. The next impact would be that the pollutants in the dome can alter weather patterns, which will contribute to the intensification of storms and other climate-related issues. So before we end the video, let's quickly look at how to reduce the effects of heat islands, as that can be asked as an essay question. So the first would be to increase green spaces, right? Plant more trees, create parks and develop rooftop gardens to increase vegetation and cool down urban areas. Another way to reduce the effects of heat islands would be through cool roofs. So use reflective materials for roofs that reduce heat absorption and help cool buildings. Another would be urban planning, right? So develop smarter cities with more sustainable designs like green spaces, better insulation, and energy efficient buildings. Another way would be through green transportation. So that basically comprises of encouraging the use of public transportation, cycling, and electric vehicles to reduce heat from vehicles. Another way is when constructing buildings, use reflective paints, as it will prevent the heat from entering the lower atmosphere. So now we will look at how to reduce the effects of pollution domes. Now again, as I said, this can also be asked you in an essay question. The first would be to regulate industrial emissions, so implement stricter pollution control measures on factories and power plants. The second way would be to reduce vehicle emissions, encourage the use of electric vehicles, improve public transport, and adopt fuel-efficient technologies. Air quality monitoring. Establish systems to monitor air pollution and enforce regulations to reduce harmful emissions. And the last way to reduce the effects of pollution domes is to promote clean energy. So shift towards renewable energy sources such as solar or wind to reduce emissions from fossil fuels. Here are some climate and weather concepts for your grade 12 exam. Anticyclones. An anticyclone is a high pressure weather system causing calm and clear weather. The winds move clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Cyclones. A cyclone is a low pressure weather system leading to strong winds and stormy weather. The winds move counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Temperature inversion. This is a condition where the temperature increases with altitude rather than decreasing. This creates a layer of warm air above cooler air. Mid-latitude cyclones. Mid-latitude cyclones are low pressure systems that form between 30 degrees and 60 degrees latitudes where cold and warm air meet. They bring rain, strong winds and changing weather as they move from west to east across South Africa. Tropical cyclones. Tropical cyclones are low pressure systems that form over warm ocean water near the tropics. They bring very strong winds, heavy rain and flooding, especially to South Africa's east coast. Cyclone families. A cyclone family is a group of mid-latitude cyclones that form and move one after the other along the same path. They often bring several days of changing weather as each cyclone passes over South Africa. Dust dome. A dust dome is a concentration of dust and pollution over a city. It's trapped by a layer of warm air above cooler air. It often happens in large urban areas and can cause poor air quality. Synoptic weather map. A synoptic weather map shows the weather conditions over a large area at a specific time. It includes temperature, pressure, wind, clouds and fronts to help forecast the weather. Anabatic winds. These are winds that flow up the slopes of mountains or hills during the daytime due to the warming of the surface by the sun. This causes the air to rise as it gets heated. Katabatic winds. These are winds that flow down the slopes of mountains or hills during the nighttime or early morning due to the cooling of the surface. As the air cools, it becomes denser and floats downhill. Convergence. Convergence refers to the process where air flows into a low pressure system from different directions. Divergence. Divergence refers to the process where air flows outward from a high pressure system. Dissipation. Dissipation refers to the process where a weather system such as a storm or cyclone weakens and loses its intensity. The system gradually diminishes in strength, leading to a reduction in wind speeds, precipitation and overall activity. Polar front. The polar front refers to the boundary or transition zone between cold polar air masses and warmer air masses around the 60-degree latitude. Moisture front. A moisture front is the boundary between a warm, moist air mass and a cooler, drier air mass. It often leads to line thunderstorms as the warm air is forced to rise. Heat island. A heat island is an urban area that is warmer than its surroundings due to concrete, asphalt and human activities. It can cause higher temperatures, poor air quality and altered local weather. Berg winds. Hot, dry winds that blow from the interior of South Africa towards the coast, typically occurring during winter months. Aspect. Aspect is the direction that a slope faces. It affects the amount of sunlight and weather conditions a particular area receives, influencing vegetation and climate patterns on that slope. Microclimates. A microclimate is the climate of a small, specific area that can be different from the surrounding region. It is influenced by factors like buildings, vegetation, water, or slope.